you think that the engines use all the fuel that we provide to them efficiently? Do you think all the fuel that is provided to engine is converted to engine power? Do you think that the earth is flat? Really? No. The answer to all of these questions would be no for most people. We will be demystifying the difference between CHT and EGT in this video. What we'll do is we'll kick off this video with understanding the law of conservation of energy. What is the law of conservation of energy? Hold on. Now before we go further, the rest of the video requires you to actually hit that like button. It's a little thumbs up in the bottom somewhere, and also hit that red button to subscribe. So the law of conservation of energy. Law of conservation of energy says that no amount of energy is created or destroyed. It is only converted from one form to the other. A very simple example would be burning of fuel. When we burn fuel, we are not destroying the energy that the fuel had. Fuel has chemical energy. We are not destroying this and it does not vanish. What we are doing is we are converting that fuel energy into mechanical energy of the piston. The piston moves back and forth. That's mechanical energy. And that movement of the piston, in case of a piston aircraft, turns the crankshaft and then rotates the propeller. Basically, we are converting fuel's chemical energy into the mechanical energy of the propeller, which further translates this into forward acting thrust. So the energy is just flowing from one state, which is chemical state, to mechanical state. State wouldn't be the right word. I would say form. It's a chemical energy changing to mechanical energy. That is law of conservation of energy, simplified for all of us to understand. Yes, it's a big science concept and you can go into much more detail, but for now, this is good. How does it apply here? We are trying to convert the chemical energy of fuel into mechanical energy of the engine that we would use to drive the propeller and or rotor blades in the case of turbine engine. The engines of piston aircraft do not convert 100% of the chemical energy of the fuel into mechanical energy that drives the propeller. Rather, a huge portion, a huge chunk of it is lost in the form of heat. Yep, that's right. The heat that the engine produces is actually a wasted energy or wasted fuel. Even sound can be arguably wasted energy. But that's too much physics. The energy should or could have been hypothetically employed to turn the propeller, but it was wasted in the form of sound and heat. All the engine designers, everyone is trying to make this wastage minimum. And that is what going towards more fuel efficient engines, going towards greener fuels, greener engines, etc. works. And if I'm not wrong, NASA issued an award to Boeing for a green single aisle airline aircraft project. You can look into it. If I find it, I'll put it in the description. So now we know what law of conservation of energy is and what does fuel efficiency mean and how it is wasted in the form of heat and sound. Generally, we have two engine instruments, CHT and EGT, in all the aircrafts. What are the things that they measure? CHT and EGT are measured using thermocouples. Thermocouples are like thermometers which measure the temperatures of the aircraft. CHT is measured using thermocouples on the cylinder walls, on the head of the cylinder, on the outside. This is the energy that is wasted as heat. Because CHT is measured on the cylinder head, we can think of it as the energy that should have been used to move the piston that was wasted as heat energy on the walls of the cylinder. Okay? Exhaust gas temperature, on the other hand, is measuring exhaust gas temperature. It is used to measure the temperature of the exhaust gases, which are a byproduct of combustion. If exhaust gases are hot, it means that the combustion is taking place correctly. If CHT is high, it means that the engine is wasting a lot of the energy in the form of heat. You need to understand this difference. High CHT is bad. High EGT might not necessarily be bad. Rather, it might indicate efficient fuel combustion. If you have a high CHT, it means that the engine is under a lot of stress. It is not producing a lot of mechanical power, but the heat and the energy from the combustion is wasted on the cylinder head instead of going and pushing the piston, turning the crankshaft, and rotating the propeller. If the exhaust gas temperatures are high, it means that the combustion process is taking place correctly and the fuel is burned efficiently enough to produce high amount of energy, which is an indication that least amount of fuel is wasted as byproducts that the exhaust gas carries. It's a lot of science, it's a lot of small things that connect with each other. Here is also where you have to understand that this is exactly the reason we use peak EGT for leading the mixture rather than CHT, because EGT is an indication of how efficient the fuel is burning. CHT is an indication of how much heat energy is wasted. That is why we use EGT in most general aviation aircraft to measure how efficiently fuel is burning. Since we are talking about leading, when will peak EGT be reached? Peak EGT will be reached whenever the stoichiometric ratio of 1:14.7 is reached. This is the stoichiometric ratio of fuel to air. How do we use this ratio? 1 pound of fuel for every 14.7 pounds of air, or vice versa. Like 14.7 pounds of air is required to efficiently burn 1 pound of fuel. Peak EGT will be reached whenever you are close to or at the ratio of 14.7, irrespective of what aircraft you are flying. This is a scientifically derived ratio and it cannot be changed, because that is exactly the right amount of oxygen required to oxidize all the hydrocarbon chains in the fuel. Anytime the mixture is not in this ratio, the EGT will be lower, and that's why we want to lean it to peak EGT to know that we are using the fuel in the most efficient manner. Not at the peak, the combustion is not 100% efficient. And that is it. That is about EGT and CHT. Of course, I want to talk about leaning as well, proper leaning procedures and how to be careful, what happens in the engine when you lean, but it's a separate video. This was just about demystifying the differences between CHT and EGT. Now that you have come to the end of the video, I'll give you a nice little bonus. The bonus is there are always two types of leaned mixtures. The one that produces the most economic fuel to air ratio, which is 14.7, which is economic because it is burning the least amount of fuel for a given amount of power. That's why it's called best economy mixture. But for most engines to be working properly and to increase their durability, it is very important to follow the POH recommended procedure. For example, in the Cessna 172, they say that you should always lean 50 degrees on the rich side of EGT. This we'll be talking about in the video whenever I make one on leaning. But there are two types of leaning and you should know about it if there is one in your POH. For those of you who are new to Propeller Pilot, what are you doing? Just subscribe, man. Go and check out my website, propellerpilot.com. It has a lot of courses for pilots, people like you who are willing to learn and make yourself better while you are in training. And also follow me on Instagram, subscribe on YouTube to be up to date with the aviation world and to whatever content I upload. Thank you. See you in the next video.